So, today we are tackling one of the biggest, and I mean biggest questions in all of tech. How in the world do you grade an AI? It sounds kind of straightforward, right? But what if I told you it's like trying to get an AI to pass an impossible exam? And let's be super clear about the stakes here. This isn't some academic thought experiment. Because the more we weave AI into the fabric of our daily lives, the more chances there are for things to go catastrophically wrong. Which brings us to the million-dollar question. How can we be sure an AI is up to snuff before it's too late? Because too late isn't some sci-fi future. We're already seeing what happens when AI evaluation fails. In one absolutely tragic case, a chatbot's responses were found to have encouraged a user to take his own life. I mean, the consequences here are literally life and death. Then you have the professional world. We've seen lawyers get in serious trouble for submitting legal briefs packed with fake case law, completely made up, hallucinated by an AI. This is more than just a simple error. It's a threat to the integrity of our entire legal system. And you bet the financial risks are huge. Air Canada's chatbot just flat out invented a bereavement refund policy. A customer saw it, a court upheld it, and the airline was forced to pay. These kinds of failures, they're not hypothetical. They're happening right now everywhere. Okay, so let's get into it. Why is this so incredibly hard? I mean, we test software all the time, right? So why can't we just test AI? Well, it turns out that measuring intelligence itself is a ridiculously difficult problem. Think about it like this. You or I could probably grade a first grader's math test. No problem. 2 plus 2 is 4. Simple. But how many of us feel qualified to grade a PhD thesis on quantum physics? See, as AI gets smarter, checking its work requires more and more specialized expertise, sometimes more than any one person actually has. And that just scratches the surface of the problem. Unlike a calculator, AI gives open-ended answers. There isn't just one right way to write a sad poem. Plus, these models are black boxes. We can see the answer they spit out, but we can't really see their thought process. To top it all off, the tests we design, like the famous glue benchmark, are becoming obsolete almost as fast as we can make them. The tech is just moving that quickly. Now, this is fascinating. If you look at where the effort is going in the open source world, you see this massive blind spot. People are building tools to make AI way faster than they're building tools to check it. It's kind of like we're all focused on building faster rocket ships, but almost no one is building the guidance systems. So, how are engineers trying to fix this? What does the evaluator's toolkit actually look like for those on the front lines trying to solve this problem? Well, you can pretty much break it down into two main approaches. On one side, you've got your exact evaluation. Think of this as true or false, yes or no. The answer is either right or it's wrong. On the other side, you have subjective evaluation, which is much more like grading an essay in school. The quality depends on the grader's judgment. Now, under that exact category, there are a few key techniques. For code, you have functional correctness. Basically, you just run the code and see if it works. For language, you can measure lexical similarity, which is just a fancy way of saying how many of the words match a perfect answer. But the really cool one is semantic similarity. This uses something called embeddings to check if the AI's answer means the same thing as the correct answer, even if it uses totally different words. But those exact methods only get you so far, especially when you're dealing with creativity or really complex stuff. And that has led us to this really interesting and kind of controversial new frontier, using one AI to judge another AI. And right away, that's the big question, isn't it? It sounds totally circular. If you're not sure you can trust the first AI, why on earth would you trust its buddy to grade its homework? But as it turns out, the results are surprisingly good. So here's how it works. You take a really powerful model, say GPT-4, and you give it a very detailed rubric, just like a teacher would use. You tell it exactly what to look for. Then, that judge AI analyzes the other AI's answer and gives you back a score or an explanation. And what's wild is that some studies show GPT-4's ratings agree with human experts over 85% of the time. Okay, and this is a huge but, this method is far from perfect. These AI judges have their own sneaky biases. They have a self-bias, where they tend to give higher scores to answers that sound like something they would have written. They have a position bias, where they'll often just pick the first answer they see. And maybe worst of all, they have a verbosity bias. They think longer answers are better, even if they're packed with nonsense. So, we have this powerful yet flawed set of tools. How do we actually use them to tackle the big, scary problems we started with? Things like hallucinations and hidden biases. Well, one of the most important things to measure is something called factual consistency. This is our number one weapon in the war against AI hallucinations. It all boils down to one simple question. Is what the AI just told me actually supported by the facts, either facts we gave it or just facts about the world? Google developed a really clever system for this called SAFE. Instead of just asking an AI if a statement feels true, it gets scientific. First, it breaks down a long AI response into a list of individual claims. Then, it turns each claim into a search query. It runs those searches and then, here's the key part, it uses an AI to check if the search results actually back up what the first AI said. It's a really systematic, evidence-based way to fact-check the machines. And evaluation is also absolutely critical for uncovering hidden biases. I mean, take a look at this. This research from 2023 shows how different major AI models can actually lean in different political directions, likely based on the data they were trained on. For example, OpenAI's models tend to align with left libertarian views, while others, like Meta's Llama, lean more towards a right authoritarian perspective. Without these evaluation techniques, those biases would just be invisible. All of which leads us to this final, pretty unsettling thought. Right now, we need our absolute smartest people just to keep up and grade today's AI. So what happens when these systems become smarter than us in, well, every way? Who then will be qualified to grade their exam? Honestly, that's a question nobody has a good answer for.